Hello and welcome. In this video, I would like to show all of you our new application for the LinkBMS system. What you currently see on the screen are two independent towers of 24 FoMoCo Mustang Mach-E 8S4P battery modules, stacked in 192S configuration. Each pair of 8S modules is connected to one 18S link slave board, like this, and of course wrapped in this kind of tape to look neat and clean. All of this is managed by LinkMaster and LinkBMS.eu, that is on top of this tower. As you can see, with this compact setup, you can achieve a little over 400 kilowatt hours of capacity and around 60 to 80 kilowatts of continuous power at 50 amps, of course depending on the battery state of charge. For inverter connection, we recommend using a 50 to 80 kilowatt Deye inverter, which is 100% compatible with the maximum possible power output of this battery. However, you can also use other brands like Sofar, GoodWe, Solis. And the list of compatible inverters is of course available on our website LinkBMS.eu. I would like to say a few words about how we build this system, the parts you will need, and the necessary steps to build one yourself. The first step, as I was telling you in a previous video about CAN modules, is of course always a voltage measurement. The voltage measurement gives you an idea of the condition of the battery pack itself, and of course it gives you the information if any of the cell is broken. The first step is of course to find broken cells, discard this module that will contain the broken cells, and if you would like to do that, you have to follow exactly the steps that I was showing on the previous video, but I will show it briefly here. You need to do two measurements divided about 1 to 3 months from each other. Of course, in the meantime, you can work on wiring, soldering, and installation. However, identifying good and bad cells is crucial for the system safety and longevity. So keep that in mind and take necessary steps to do it. In terms of connectors, we use Staubli Evo 2 connectors. They are rated for 70 amps of current and 1500 volts DC of voltage, and they are commonly used in photovoltaic parts and distribution centers in European Union, so you can easily access them. It's also pretty cheap for a connector this good. But please beware of knockoffs that look identical as these ones. Always buy from verified suppliers, as most MC4 connectors cannot handle such current. So keep that in mind when you are using MC4 connector, that it has to be a good quality one. In terms of containing this battery somewhere in your facility, consider placing the batteries in a heated and a dry environment, because these batteries and lithium batteries in general should be charged above 0 degrees Celsius. So the 0 degrees Celsius is the minimum point that the batteries can be charged. So below it's big cross, because it's not recommended by manufacturer of the cells. There is a lot of bad chemical reactions that are happening inside the cell below 0 degrees Celsius and charging. So always avoid charging below freezing, and if possible, position them outside of the living area, because even these batteries are mounted inside our electric vehicles and considered safe. They also concentrate a lot of energy, and if in case of fire this is impossible to extinguish. So please keep that in mind when placing it inside the living area, because it's a very big fire hazard. If you have any questions, feel free to leave them in the comments below. I will try to answer them all. I hope you found this video interesting. If yes, please leave like and subscribe. I will see you in the next one. Bye.